There's a moment every scientist fears. Not the moment when the data breaks, but the moment when the data is right and reality is wrong. For astronomers at the Lowell Observatory in Arizona, that moment arrived at 3:14 a.m., when a small cluster of pixels on a photometric light curve jumped 32% brighter in a span of 7 minutes, then, just as violently, dropped. No one should have noticed it. The telescope wasn't even hunting for anomalies. It was doing routine follow-up on a newly discovered interstellar object, another visitor from beyond the sun's reach, the kind we'd grown strangely accustomed to since Oumuamua and 2I Borisov. But this one, catalogued as 3I Atlas, was supposed to be quiet, boring, a dusty snowball drifting along a predictable arc past Jupiter's orbit. Instead, it breathed. That's the part that wouldn't let go of my throat the first time I saw the raw feed. It didn't flicker like a rotating rock catching sunlight at random angles. It didn't spike like a comet outburst triggered by a thawing patch of ice. It inhaled, slow, deliberate, and then exhaled into darkness again. 16 hours, 10 minutes, and 22 seconds later, it did it again. The same amplitude, the same symmetry, the same climb, the same fall. A rhythm precise enough to set a heartbeat against. Something out there was pulsing. And it wasn't supposed to exist. Stay with me, because by the end of this chapter, you'll understand why that simple light curve fractured the confidence of half a dozen institutions, why a Harvard astrophysicist quietly ran the probability of a natural origin and got a number so small it might as well have been sarcasm from the universe, and why some researchers, off the record, use a word you're not supposed to say when talking about interstellar objects: parked. If you're new here, hit follow. You're going to want to witness where this story goes, because everything after that first pulse makes the discovery look tame. But let's go back to the night when a junior data analyst in Flagstaff rubbed her eyes, zoomed in, zoomed out, recalibrated her screen 3 times, and whispered the first forbidden sentence ever spoken about 3I Atlas. This looks alive. Her name was Erin Caldwell, 24 years old, meticulous, newly hired, and terrified of making a mistake that would get her fired. She stared at the brightness spike for so long her eyes blurred. Then she blamed herself. Bad calibration, dust on the lens, satellite contamination, cosmic rays, anything except what it looked like. But when she pulled the last week of photometry from the archive and aligned the timestamps, the pulses snapped into place like teeth on a gear. Brightness rise, plateau, collapse. 16 hours, 10 minutes, and 22 seconds between each crest. If you're listening in your car or on a walk, you might shrug. So what? Objects spin, comets flare, space is weird. Except this wasn't rotation. That was the first wall the data punched straight through. A rotating object changes brightness because its reflective surface area changes relative to the observer. You see more of it, it shines brighter. You see less, it dims. That's Astronomy 101. Kids learn this in high school physics. But Atlas was too small, too dim, and, most importantly, its nucleus contributed less than 1% of the total light. Hubble data confirmed that later, but even at the beginning, Erin could tell something was off. The amplitude of the pulse was far too large. You don't get a 30% swing from a nucleus that barely contributes anything, which meant the brightness wasn't coming from the solid body at all. It was the coma, the cloud of gas and dust around the nucleus, expanding and collapsing like a lung. She needed confirmation. She needed someone older, someone calm. So she forwarded the file to her supervisor, Dr. Greg Marshall, a man who had once described comets as pathetic little coughs of ice pretending to be majestic. He wasn't easily impressed, but 2 hours later, he drove back to the observatory in pajama pants. When the second pulse came in, Aaron watched his face in the glow of the monitors. A man who'd spent 30 years studying dead things in space was looking at something that behaved disturbingly like it wasn't dead. He didn't say alive, but he also didn't say comet. He said nothing at all. The news reached Harvard within 48 hours. Now, if you know anything about the politics of astrophysics, you know exactly which office it landed in first. Avi Loeb read the report before breakfast. To be clear, whether you agree with his theories or not, Avi has a talent for recognizing when data refuses to sit quietly in its assigned box. He's controversial not because he's reckless, but because he refuses to pretend anomalies are boring, and Atlas was the purest anomaly he'd seen in years. He opened the photometry, he replicated the period, he tested rotation scenarios, he ruled out the nucleus, he checked thermal models, he ran sublimation simulations. Then he did something dangerous. He ran the probability that a random interstellar object would pass through its current trajectory, skimming Jupiter's hill sphere at the precise angle needed to enter its present orbit naturally. The number that came back was absurd. 0.00005%, 5/10,000ths of a percent. You can dismiss that if you want. Numbers don't care. They just sit there, cold and honest. And that one sat there like a quiet accusation. Something about Atlas felt intentional, or at least not accidental. But that wasn't the part that detonated across the scientific community. It was what Avi said next. He proposed the breathing coma model. He said the pulses weren't reflections or outbursts. They were rhythmic ejections of gas and dust released like timed jets, massive ones, thousands of kilometers across, each cycle expanding the coma by roughly 25,000 kilometers before it thinned again. That would mean Atlas was not a passive object. It was doing something. Imagine the response. Half the community dismissed him immediately. The other half bookmarked the preprint and read it twice. Because here's the part no one could explain away. The pulses were too regular, too clean, too precise. Nature repeats, yes. Stars pulse, neutron stars pulse, variables pulse. But comets? Comets are chaos in slow motion, and Atlas was the opposite of chaos. It was clockwork. By July 1, the story hit the news. By July 3, NASA convened a closed-door working group. By July 5, the Hubble team was called in for high-resolution imaging. The public saw none of that. All they saw was a short press release that said in the driest language possible that 3I Atlas exhibited unexpected photometric behavior warranting continued observation. Behind that phrasing was panic. Hubble's images came back smeared and ghost-like because the object was moving so fast relative to the stars, but one detail cut through the blur. 7 jets. 7 distinct plumes of material radiating from the coma. Not one, like you'd expect from a rotating ice patch. 7. If you've ever seen a diagram of spacecraft attitude thrusters, your brain might have twitched the way mine did. It was too early for that, too reckless to think it. But the symmetry, the angles, the spacing, it wasn't random. At least one of those jets appeared not just misaligned with the sun, but pointed directly toward the sun. A sunward jet. Natural comets don't shoot material toward the star heating them. That's like exhaling into a blowtorch. The simplest explanation, the jet wasn't thermal. which leaves you with the uncomfortable category scientists avoid unless absolutely forced: non-thermal mechanisms, or worse, directed mechanisms. But no one was ready to say that out loud. Instead, they ran models, endless ones, simulations that melted GPU clusters at MIT and Caltech. Somewhere in the early attempts, someone joked about adding a just because variable to explain the jets firing in directions that made no physical sense. No one laughed, because the more the data came in, the clearer the shape of the problem became. The coma wasn't expanding because of sunlight. It was expanding because something underneath was venting deliberately, rhythmically,
Repeatedly. It wasn't rotation. It wasn't chaos. It wasn't geology. It was behavior. Now, I need you to picture something. Not a graph, not a telescope render, not a scientific instrument reading. Picture this. You're standing alone outside at night. The desert is cold. The observatory dome is open behind you. You look up, and somewhere far beyond what your eyes can see, an object the size of a small mountain is drifting through the dark. Every 16 hours, it exhales a plume of gas wider than the earth. Not once, not randomly, but like a breath on repeat. If you felt a shiver, that's normal, because that's what the astronomers felt too. It wasn't fear of aliens. It wasn't fear of impact. It was the fear of encountering something the universe has no precedent for, something that forces you to update your understanding of reality in real time. We humans like categories. We like definitions. We like nature to behave like nature. But Atlas did not care. And that's when something else happened, something that took this from strange to alarming. On July 12th, an NOOA atmospheric scientist named Dr. Jonathan Ruiz noticed a tiny dip, barely measurable, in the global ozone data collected by the SUMI NPP satellite. Nothing dramatic, a 0.3% deviation, the kind of thing you'd ignore without a second thought. Except he didn't ignore it. He marked the timestamp. And 2 days later, when the next dip occurred, this time 0.5%, he overlaid the pulses of 3I Atlas onto his atmospheric graph. The dips aligned exactly, to the minute. Ruiz hesitated. He cross-checked. He recalculated. He blamed instrumentation drift. He blamed the algorithm. He blamed his exhaustion. Then came the third dip, stronger, sharper, and impossible to dismiss. It wasn't a loss of ozone. That would be a tabloid oversimplification. It was something subtler, more unnerving. A temporary chemical disruption in the upper atmosphere, localized but global in effect, like a thin scar that healed within hours but left a fingerprint in the data. And each scar appeared right after a pulse. Ruiz didn't tell the public. He called NASA, then NOOA, then the White House Science Advisory Board. By the time they responded, a fourth pulse hit. This one left a measurable 1.1% disruption. That was no longer subtle. That was not noise. That was a signature. Something was reaching Earth. Something invisible. Something tied to the rhythm of Atlas. Something that shouldn't travel across hundreds of millions of miles with that much coherence. And that's where I need to leave you, for now. Because what happens when the scientific community realizes that an interstellar object may not just be doing something, but affecting us, is the beginning of a different story entirely. One where the stakes are no longer theoretical. One where fear stops being abstract. If you thought a breathing comet was strange, wait until you see what happens when Earth starts responding. If you were standing in the NOOA headquarters that morning, you wouldn't have known anything was wrong at first. People still carried coffee cups. Screens still flickered with weather models, ocean heat maps, hurricane trajectories spiraling off the Gulf. It was normal. Ordinary. The quiet before a seismic shift that no one recognized until it was impossible to ignore. Dr. Jonathan Ruiz sat alone in a glass-walled conference room, flipping through atmospheric graphs like a man trying to disprove his own eyes. He wasn't supposed to be looking at interstellar object correlations. His job was seasonal ozone pattern analysis. Predictable. Methodical. The kind of work where anomalies are usually small enough to ignore. But not this time. He zoomed in on the fourth disruption, the latest scar the atmosphere had taken. The numbers didn't flinch. 1.1% deviation across high-altitude ozone concentration. A rupture so faint the average person would never notice it, but so precise that it haunted him. It wasn't the magnitude that terrified Ruiz. It was the shape. It was the same pattern every time. A sudden dip, a sharp trough, a clean, almost mechanical climb back to baseline. Nature doesn't stitch yourself back together with machine-like precision. Nature is messy. But this was a signature. Ruiz leaned back, rubbing his temples. A thought pressed against his mind like a cold fingertip. This is intentional. He didn't want to say it. Didn't want to give it language. Language makes ideas real, and real things demand responsibility. But the correlation was perfect. Every time 3i Atlas pulsed, Earth's atmosphere reacted as though someone had fired a silent, invisible beam across millions of miles of vacuum, and it arrived intact. Ruiz exhaled slowly. His breath fogged the glass door. Then his phone buzzed. A message from NASA's Atmospheric Division. "We see your data. Do not share externally. Call in 10 minutes." He stared at the message for a long time. Something inside him tightened. Across the country, at the Harvard Smithsonian Center for Astrophysics, Avi Loeb stood before a whiteboard covered with equations that had stopped making sense sometime around midnight. The pulse timing, the coma expansion rate, the jet geometry, everything pointed toward a system operating on internal logic, not external forces. He erased a portion of the board, rewrote it, erased again. Nothing fit. He wasn't alone. 2 postdocs watched silently from behind stacks of data printouts. "Try the solar-driven model again," one of them said, though her voice was already defeated. Avi didn't look up. "We've run that model 7 times. "Run it again." He sighed, keyed in the parameters, and let the simulation crawl forward. The digital model spun, lit, breathed heat. As expected, the predicted brightness curve diverged from reality within minutes. The real object pulsed with clockwork precision. The simulation decayed into chaos. We're forcing a natural explanation on something that doesn't want to be natural. Avi murmured. The room went silent. He didn't mean want literally. Scientists aren't supposed to anthropomorphize cosmic objects. But the phrasing leaked out anyway. No one corrected him. The universe, it seemed, had begun misbehaving. Meanwhile, in a secure basement room beneath the NASA Goddard Space Flight Center, 8 experts sat around a table that still smelled faintly of sanitizer and cold metal. Ruiz's atmospheric disruption report was on the center screen. A woman in a navy blazer tapped her pen, her face unreadable. "So you're telling us," she began, "that Earth's upper atmosphere reacts to a deep space object on a 16-hour cycle." Ruiz swallowed. "Yes. And this correlation, statistically? It's beyond coincidence." There was no drama in his voice, just exhaustion. Another official leaned forward. "Could this be solar activity, interference, particle storms?"
Ruiz already had the graphs ready. Solar output was flat. No proton events, no geomagnetic disturbances, nothing that matches the timing. A third voice chimed in. Could it be an instrumental artifact? Ruiz zoomed in on the data from the European Sentinel P5. 3 satellites, 3 independent systems, identical signatures. Silence. And then, what's the working hypothesis? Ruiz hesitated. His pulse quickened. He didn't want to say it, but someone else did. A middle-aged physicist with tired eyes murmured almost reluctantly, "It's a directed emission." No one breathed. He continued, voice low. Something leaves that object, travels through space, interacts with our upper atmosphere, and dissipates. The woman in the navy blazer folded her hands. Are we talking about energy, radiation, charged particles? Ruiz answered quietly. It's not radiation in any category we monitor, and not charged particles either. There's no ionization trail. Whatever it is, it passes through space cleanly, as if space isn't even there. A shiver crawled up someone's arm. Directed emissions across interplanetary distances are not the realm of geology or passive objects. They're the realm of systems, of mechanisms. And this happens, she said, every time the object pulses? Ruiz nodded. Exactly when it pulses. For a moment, the room felt smaller. Then she said the sentence no one wanted to hear.
The table fell silent again, because if this was a message, the Earth was standing in the crossfire. 2 days later, the 5th pulse hit, and this time it wasn't 1.1%, it was 1.6%. The atmospheric rupture widened, deepened, lasted longer before recovering. The pattern was unmistakable now, exponential strain. Something was escalating. Ruiz watched it happen live from his dimly lit home office, palms sweating as if he could feel the chemicals rearranging miles above him. The graphs danced, curved, collapsed. The pulse's echo carved another wound into the ozone layer, like the thumbprint of something brushing past the Earth. He muttered the numbers under his breath, as if saying them out loud might force them to shrink. But the numbers were merciless. A sharp knock rattled his apartment door. Ruiz froze. It was nearly midnight. The knock came again, firmer this time. "Dr. Ruiz, NASA Security, we need to speak with you." By the time dawn broke over the East Coast, a classified briefing had been scheduled at the White House. Not because anyone believed Earth was in immediate danger, but because no one could answer the most important question. What happens if these pulses grow stronger? No one dared suggest the obvious second question. What if Atlas isn't malfunctioning, but warming up? Let me take you now to the Mount Lemmon Observatory in Arizona, 26 hours after the 5th pulse. A young astronomer named Maya Green stood beside the main telescope, her fingers stiff with desert cold despite the summer heat. She'd been assigned to obtain time series images of Atlas, mostly to appease the data-hungry modeling teams across the world. But as she processed the latest exposures, she frowned. Something about the coma looked different. She blinked, adjusted contrast, sharpened the image. There, along the sunward side of the object, was a faint, needle-thin extrusion of light. It wasn't a jet. Jets bloom outward. They diffuse. They dance. This line didn't dance. It held its shape, its direction, like a laser, like a pointer, like something aimed. Her breath caught. "Professor Marshall," she called, "can you come here?" The older man stepped behind her, squinting at the screen. The thin beam etched across the darkness like a whisper from a machine. Marshall exhaled through his nose. "That's not natural." "Is it pointing at us?" she asked. He didn't answer. He didn't have to, because the direction of that line, its angle,
Its inclination matched something NASA was already losing sleep over: the axis of the atmospheric disruptions, not by coincidence, but by geometry. At Langley, at JPL, at the Applied Physics Lab, models began to converge. They all showed the same thing. If Atlas's next pulse followed the strengthening trend, Earth would pass through a denser region of the emission cone,
And the ozone rupture could exceed 2%. Some simulations predicted 3%. One worst-case model projected 4.2%. If you're thinking that's small, let me stop you. A 4% compromise in ozone concentration over even a fraction of Earth can increase surface UV radiation to levels that scorch plankton, alter cloud chemistry, and trigger cascading ecological damage. But that wasn't the terrifying part. The terrifying part was how fast it healed, as if whatever passed through the atmosphere did exactly what it was meant to do, and then faded. That is not how natural radiation behaves. That is not how particle showers behave. That is not how sunlight behaves. This was targeted. Pulse-shaped. Transient. The atmospheric signature wasn't random destruction. It was the residue of an event, a controlled one. Now let me tell you about the sixth pulse. It hit at 2:04 a.m. Eastern Time. Most of the world slept through it, but in a basement at Goddard, 12 scientists watched every second unfold on layered graphs and anxious telemetry readouts. The brightness of Atlas climbed, the coma expanded, the jets flared, and then something new. A low-frequency oscillation, barely detectable, a vibration in the light curve itself. As if the object wasn't just pulsing, it was signaling. Moments later, Earth's atmosphere rippled. A 1.9% rupture, longer recovery, sharper trough. Ruiz felt his stomach drop. Because this time, the disruption wasn't global. It was focused, a band stretching across the southern Pacific. Like a sweep, a scam, a system mapping something, or someone. Ruiz whispered, "Why that region? Why that angle?" The physicist beside him muttered, "It's following the magnetic field lines." Ruiz shivered. Because if Atlas was interacting with Earth's magnetic field, then it wasn't just releasing emissions, it was reading something. 20 minutes later, NORAD detected a faint but measurable disturbance in the magnetosphere. Nothing dangerous, just enough to register. Enough to confirm a chilling possibility. Earth wasn't an accidental target. It was being sampled, or surveyed, or tested. NASA didn't sleep that night. Neither did the White House. Neither did Avi Loeb, who stood alone in his office gazing at a simulation of Atlas rotating in silence. For years, he'd argued that interstellar objects could be technological probes, remnants or scouts of ancient civilizations, but he never imagined he would live to see one behave like one. He whispered to no one, "What are you doing out there?" And the universe, vast and indifferent, offered no answer. The next morning, a new discovery arrived. A radio astronomer at the Very Large Array in New Mexico detected an ultra-low frequency burst occurring milliseconds after each pulse. Far below normal cosmic noise, too structured to be random, too faint to be a broadcast. It wasn't a message, it was a side effect, like the whine of an engine, like the hum of machinery. Something inside Atlas was working. Something with components, cycles, power. Ruiz wasn't the only one losing sleep now. Fear was spreading person to person, lab to lab, like a silent contagion. Because humanity had never confronted this question seriously. What do you do when an interstellar object is not passive, not inert, not indifferent, but active? And what do you do when it begins touching your planet? I'm going to leave you with this.
3 hours after the sixth pulse, NASA analysts reconstructed the atmospheric disruption band over the Pacific. It wasn't random. It wasn't lopsided. It was shaped. A curve, an arc, a geometry that looked almost like a footprint. As if something had brushed across the planet not to damage, not to communicate, but to locate something, or confirm it. If that doesn't send a chill down your spine, then part 3 will. Because we've reached the stage where Earth is no longer just observing Atlas. Earth has become part of its algorithm. Stay with me. You don't notice the moment fear becomes policy. It doesn't arrive with alarms or headlines. It begins quietly, in the spaces between conversations, in the thin cracks where uncertainty pools. At first, it was only a handful of scientists exchanging uneasy glances during meetings, the way people do when they all sense the same ghost but are afraid to say its name. But after the sixth pulse, after that sweeping signature carved itself over the southern Pacific, fear began to coalesce into something heavier, something organized, something that felt like the first tremor before a fault line gives way. Because the sixth pulse didn't just disrupt the ozone, it didn't just skim the magnetic field, it didn't just whisper through the radio spectrum. It did all of that, and then it left behind something that no one was prepared for. A shadow. Not a literal one, not darkness spreading across the sky, nothing visible. This shadow existed inside the data streams themselves, an absence, a distortion, the echo of an interaction no instrument was built to detect. A shape in the missing information, like someone had brushed their fingers across the raw physics of the planet and smudged it. The first person to notice it was a woman named Dr. Amelia Kent, a computational physicist at MIT whose job was to filter noise from satellite telemetry. She'd been up for 20 hours when she saw the hole. A small cluster of data points, missing timestamps, omitted packets. Nothing unusual by itself. Satellites glitch.
Systems lag. But these gaps weren't random. They formed a curved interval across multiple systems, as if every satellite in a certain orbital path had blinked out at the precise microsecond. She enlarged the plot, overlaid magnetometer readings, atmospheric logs, radiation indices. The gaps aligned, a perfect arc matching the ozone disruption geometry Ruiz had identified. Her jaw tightened. This wasn't a glitch. This was an imprint. Something passed through Earth's upper atmosphere and for a fraction of a second interfered with instruments across the globe. Not with electricity, not with magnetism, not with radiation, with something else, something unknown. She forwarded her findings to NASA. They replied within minutes. Secure your workstation. Do not share data. Prepare for remote conference. The call began an hour later. 18 faces appeared, each one lit by the icy glow of screens. Kent showed them the arc, showed them the timing, showed them the atmospheric overlap, then the magnetospheric alignment. When she finished, the room was silent. A man from the Jet Propulsion Laboratory finally spoke. "Are you saying the object is interacting with Earth? On purpose?" Kent shook her head. "I'm saying the interaction is too clean to be incidental." A woman from the Department of Energy leaned forward, her face tense. What mechanism could cause this kind of multi-system interference? Kent's throat tightened. "None that we know of." Someone whispered, "Then how the hell is it doing it?" No one had an answer. Meanwhile, on the other side of the country, at a small observatory in Oregon, a graduate student named Luke Harrison was staring at an entirely different problem. He wasn't studying Atlas. He wasn't even following the news. His work focused on deep field imaging, mapping distant galaxies for lensing effects. But as he processed a routine exposure, he froze. There, streaking through the corner of the frame, was a faint linear smear. Not a meteor, not a satellite. The smear was angled wrong. too slow for space debris, too fast for natural orbital movement. He enhanced the image, and his stomach dropped. The smear wasn't fading like a tumbling object. It was pulsing. 16-hour interval pulsing. He looked up sharply. "Oh God," he whispered, because Atlas wasn't supposed to be visible from this location at this time. Its projected path placed it at a different angle entirely. Unless Atlas had changed trajectory. Unless it had moved. He checked the almanac, checked the coordinates, checked the ephemeris from JPL. All wrong. The object was several arc-minutes off its predicted path. He sent an urgent alert to the Minor Planet Center. They responded faster than he expected. "This deviation has been noted. Do not discuss externally." Luke swallowed. He realized the truth before anyone said it. Atlas wasn't drifting. Atlas wasn't falling. Atlas wasn't passively obeying gravity. Atlas was steering. By the next morning, world governments knew. Every closed-door meeting started with the same unthinkable phrase. The object is exhibiting non-gravitational acceleration. This is the technical term used when celestial bodies behave like they have engines. But the officials were careful. No one used the A word. No one said artificial. Instead, they used words like analytic influences, outgassing discrepancies, interpretive uncertainty. None of it mattered. Everyone understood. Something was adjusting the object's trajectory with precision. Something controlled. And while the public still believed Atlas was just another interstellar curiosity, every expert in orbital mechanics was staring at the same nightmare possibility. If it was steering, what was it steering toward? A new pulse struck, the 7th, and this one crossed a line. It hit at 9:17 p.m. Eastern Time. The pulse was brighter, sharper, longer. Within minutes, the ozone disruption appeared, 2.4% this time. Ruiz watched from the NOAA war room, his heart pounding. Then a second disruption appeared, then a third. 3 scars, 3 distinct atmospheric wounds, as if the pulse had split into multiple beams. Ruiz looked around the room. "It's branching." A man beside him whispered, "It's scanning." Another added, "Or targeting." But the atmosphere wasn't the only thing affected. The magnetosphere flared. Radio telescopes glitched. Star trackers aboard satellites flickered, lost lock, then regained it. Across multiple observatories, the comet's coma shifted, not randomly, but with sudden geometric alignment, as if panels had moved beneath the ice, as if something inside had repositioned components. One astronomer said it aloud, breaking the unspoken taboo. "It looks like calibration." No one protested. Not this time. Because the new light curve was too regular, too structured. The peaks were symmetrical now. The troughs matched like mirrored signals. The object wasn't just pulsing, it was tuning itself. Like an engine warming, like a system updating, like a machine preparing for a new operational phase. Now let's return to Dr. Amelia Kent, because while the world's agencies scrambled to interpret the 7th pulse, she saw something everyone else missed. She noticed a faint ripple in the magnetometer logs 6 minutes after the ozone disruptions, 6 minutes after the emission branching, a secondary fluctuation, weak but unmistakable. She layered it against the previous pulses. It was present in all 6, but so faint no one had caught it. Only this time, it was stronger. She isolated the pattern. She analyzed the spacing. And her stomach turned. The ripple wasn't random. It wasn't noise. It was repeating. A pattern. Not identical, but iterative, like a sequence adjusting based on feedback. It reminded her of something she hadn't thought about in years. Active sonar. A system sending a pulse, waiting for a return, and recalibrating based on what it learns. But sonar only works in water, and sound cannot propagate through space unless the sound wasn't sound, unless the mechanism wasn't acoustic, unless Atlas was probing the Earth. Kent closed her eyes, then whispered the sentence that once spoken could never be taken back. It thinks we're something worth mapping. 6 hours later, NASA quietly contacted the United States Space Force, not because they believed Earth was under attack, but because no one knew how to define what was happening. Space Force brought in orbital analysts. They confirmed Luke Harrison's suspicion. Atlas had changed trajectory again, subtly, deliberately. It was adjusting its course toward Earth, not directly, but enough that in astronomical terms, the deviation was unmistakable. Someone in the briefing whispered, "Is it coming to us?" Someone else whispered, "Is it coming for us?" And then they stopped whispering entirely. Because the next simulation projected something horrifying. If the pulses continued increasing, if the atmospheric scars grew deeper, if the magnetospheric interactions intensified, Earth's upper atmosphere could reach a critical threshold, a point where the ozone rupture becomes nonlinear, where healing slows, where ultraviolet radiation climbs exponentially, where life begins to feel the burn. Not extinction, not apocalypse, not Hollywood, but the first measurable touch of something humanity had never faced before. A technological system operating across astronomical distances, interacting with a living world. Now focus with me, because this next moment changed everything. It happened during a midnight emergency session at the Applied Physics Lab in Maryland. Specialists in plasma physics, particle dynamics, astrophysics, and atmospheric chemistry gathered around a single projection. The leading hypothesis was split. 4A. Atlas was releasing a directed emission, a beam or pulse, interacting with Earth. 4B. Atlas was influencing the sun or magnetosphere indirectly, triggering secondary effects. Both were bad. Both were unprecedented. But then a new model appeared on the screen, one no one had considered because no one wanted to. It combined both, a hybrid mechanism, direct emission and solar modulation, a system that used the sun as a carrier, amplifying its own pulse through solar-wind interaction, like a surfer riding a wave. The room fell silent, because if this model was correct, then Atlas wasn't just reaching Earth. Atlas was using the largest energy source in our solar system to deliver something to us. Something precise, something adaptive, something intentional.
A woman in the back finally breathed. So what is it trying to do? The man beside her answered without looking up. It's looking for something. Hours later, a new discovery pushed the situation from dangerous to surreal. A team at the University of Colorado detected an anomaly in the ionosphere. A thin ribbon of charged particles twisting in a shape no natural phenomenon produces. Ruiz saw the shape on the screen, and for the first time since the pulses began, he felt actual fear, not for the ozone, not for his job, not for science, for humanity. Because the shape wasn't random, it wasn't chemical, it was geometric, a perfect spiral. Not mathematically perfect, organic perfect. The kind of perfection that suggests intent rather than accident. And the spiral wasn't alone. It was rotating. Rotating at, Ruiz checked the numbers again, 16 hours, 10 minutes. The rotation of the spiral matched the breathing cycle of Atlas. The object wasn't just affecting the Earth, it was creating a patterned resonance in our ionosphere, a structure tied directly to its pulse. a signature, a beacon, or a marker. Ruiz felt cold all over, because the spiral wasn't aimed outward into space. It was aimed downward, toward Earth, toward us. Let me pause for just a moment, not to slow the story, but to let the stakes settle in your chest. Up to this point, humanity had been watching Atlas, with fascination, fear, curiosity. But now, Atlas was watching back. Not randomly, not indirectly, but through a structured interaction so precise it bordered on comprehension. Something out there had found us, and was measuring us, and was adjusting itself as if preparing for the next phase, whatever that phase was.
The eighth pulse was coming. Predicted arrival, 29 hours. And every model pointed to one outcome. The next pulse would not just mark Earth, it would change Earth. What happens next? That's part 4. And trust me, you're not prepared for what Atlas does when it decides it needs more than data. Stay with me. There are moments in history when the world seems to hold its breath. Moments when clocks feel louder, seconds feel sharper, and every human being, scientist or not, senses that something is coming. The approach of the eighth pulse was one of those moments. 29 hours. That's how long the world had to prepare. 29 hours to wait for something no model could predict, no theory could contain, and no government could control. NASA didn't issue a warning. The White House didn't issue a statement. But people felt it anyway. The air was tense, animals restless, global instruments humming with the kind of pre-event tension that usually precedes a solar storm. Only this wasn't the sun. This wasn't nature. This was 3I.ATLS, an object that had already scarred the ozone, bent our magnetosphere, shifted its trajectory, branched its emissions, and, according to a terrifyingly small number of scientists, mapped us. And as the countdown ticked away, something else happened. Scientists started to panic. Not because the ozone loss might increase, not because the magnetosphere might destabilize, not even because Atlas might be artificial. They panicked because, for the first time, the object stopped behaving predictably. The curve flattened, the pulse interval drifted, the light emissions began to fluctuate. No more metronome rhythm, no more mathematical precision. Atlas was changing tempo, as if preparing, as if adjusting, as if gathering energy for something far bigger than any pulse before. At the NOAA Atmospheric Research Center in Virginia, Dr. Elias Ruiz leaned over the workstation, rubbing both hands over his face as if he could physically push the fatigue out of his skull. He had been awake for 39 hours. Behind him, 2 technicians argued about whether the branching might cause a runaway cascade in the stratosphere. He ignored them. His eyes were on the new data. The ozone depletion rate from the 7th pulse plotted against the projected trajectory shift. There was no denying it now. The ozone wasn't just thinning in patches, it was fracturing, breaking in irregular, jagged shapes, like ice cracking under stress. Ruiz whispered, "This isn't degradation, it's structural stress." The technician beside him frowned. "Atmospheres don't have structural stress." "No," said Ruiz, his voice barely audible. "Not unless something is forcing it." He zoomed in on the model. Each pulse had created a thin atmospheric wound. The wounds weren't healing. They were linking, connecting lines, forming a global pattern, a pattern that matched, Ruiz felt his stomach twist, the geometric spiral discovered in the ionosphere. The 2 phenomena weren't separate. They were part of a single planetary-scale structure. Atlas wasn't merely disrupting the atmosphere, it was shaping it. Across the country in California, Dr. Amelia Kent stared at the new magnetometer logs. The secondary ripple she had discovered earlier, the sonar echo, was changing, growing stronger, more coherent, more structured. It no longer resembled an echo. It resembled a signal. She overlaid the ripple with the ionosphere spiral rotation data. The match was horrifying. The ripple frequency was now synchronized with the upper atmosphere spiral rotation. Impossible, she whispered. But the evidence was right there, pulsing steadily. Atlas had established a resonance with the Earth's upper atmosphere, like tuning a string on a musical instrument, like preparing the air itself to vibrate. And then something even more impossible happened. A second ripple appeared, a weaker one, offset by a few degrees, almost a harmonic. Kent froze. "This is communication," she whispered. "This is active feedback." Her assistant leaned closer. Feedback with what? Kent swallowed. With itself. Meanwhile, at the Jet Propulsion Laboratory in Pasadena, mission specialist Harper Lynn watched the trajectory simulations blur across her screen. "What the hell is going on?" she murmured. The simulation wasn't predicting one path anymore. It predicted six. 6 diverging potential trajectories. 6 different movement patterns. 6 course corrections, each one tied to the timing of the upcoming pulse. "Run it again," she said. The system ran the simulation. Same 6 paths. Again. Same 6. Her colleague leaned over her shoulder. "What does it mean?" Harper exhaled slowly, the truth forming even before she allowed herself to say it. "It means Atlas hasn't decided which way it's going yet." That chill in her voice spread across the room like frost, because celestial objects don't decide. Machines do. Back in Oregon, Luke Harrison stood alone on the rooftop platform of the Pine Ridge Observatory. Wind howled around him, tugging at his jacket. Clouds churned overhead. He aimed the telescope again. Atlas was still barely visible, a faint, flickering smear. But something was different. The coma wasn't symmetrical anymore. It wasn't even comet-like. It was stretched outward, formless at first, then sharper. Edges, lines, angles. Luke blinked. There were straight edges inside the coma, geometries that could not be natural, shapes that resisted sublimation, resisted randomness, resisted physics. Shapes like struts, like plates, like panels shifting beneath a translucent veil of dust and gas. He stepped back from the eyepiece. No. He rushed inside, scrambling to upload the frames, but before he could send them, a new alert pinged across every monitor. Global Early Warning System. Magnetospheric destabilization detected. Luke stared at the message. The 8th pulse hadn't even arrived yet, and the Earth was already reacting. By dawn, government agencies around the world were engaged in silent panic. Atmospheric scientists tracked the ozone fractures expanding like frost patterns. Astrophysicists watched Atlas's light curve develop a sawtooth shape, as though the pulse was compressing itself. Geomagnetic experts saw the magnetosphere dimpling inward. Radio observatories picked up faint rhythmic distortions. And in the classified satellite division, analysts noticed something chilling. Atlas had slowed down. Not by much, just enough to confirm the worst-case hypothesis. It was preparing to fire something stronger than any previous pulse. The countdown reached 6 hours. Ruiz stood before a wall of monitors, heart hammering. NOAA's supercomputer projected something new. The atmospheric fractures would not simply heal more slowly after the 8th pulse. They could propagate, like cracks in a pressure dome, like an unstabilizing resonant structure, like an atmosphere being forced into a shape it was not built to sustain. His mind raced through every atmospheric model he had ever studied. He whispered, "No natural object can do this." A senior chemist turned towards him. "Then what is it?" Ruiz didn't look away from the screens. "It's a controlled energy system, one interacting with Earth." The room went silent. "And if we're right," Ruiz continued, "then the next pulse won't just damage the ozone." He pointed at the simulation. "It'll reshape it." 5 hours. At MIT, Amelia Kent plotted the second harmonic ripple. It now overlaid perfectly. She felt a pressure building, not in her chest, but in her mind, an intuition she didn't want. 2 signals, 2 frequencies, a carrier wave and a modulation, a transmission protocol.
Atlas wasn't scanning. It was communicating, not with Earth, but with whatever resonance pattern the pulses were carving into Earth's magnetic and atmospheric layers. She whispered, "It's preparing the medium." Her assistant frowned. "For what?" Kent replied with a dry mouth, "For the message." 3 hours. At Pine Ridge Observatory, Luke Harrison lost visual contact. Atlas disappeared, not behind clouds, not below the horizon. It dimmed, its coma faded, its emissions collapsed, as if the object were absorbing its own light, coiling inward, drawing energy. The pulse was imminent. 2 hours. At Space Force Command in Colorado, analysts confirmed the circular logic no one wanted to believe. Atlas's shift toward Earth was no longer theoretical. The new trajectory, no matter how far projected, always curved inward. Not collision course inward, close pass inward. The object was aiming for an altitude range where its pulses would hit the Earth with maximum atmospheric penetration. A precise altitude, a chosen altitude, a targeting altitude. Someone whispered, "Why that height?" The room's chief orbital physicist answered, "Because that's where communication is clearest." 1 hour. Kent's magnetometer data spiked so violently she thought her system fried. The ripple became a roar. The second harmonic expanded. A third appeared, then a fourth. Her hands shook as she realized what she was looking at. A sequence, designed, structured, not noise, instructions. This is a transmission protocol," she whispered. Her assistant swallowed. "A message." "No," she said, "a handshake." 30 minutes. Ruiz watched as the ozone fractures sharpened into something geometric. 3 lines, curved, intersecting. His breath caught. "It's matching the spiral." A unified atmospheric pattern spanning the entire hemisphere, like Atlas was aligning the Earth itself. "Why would it do that?" the technician asked. Ruiz stared at the map, feeling a cold understanding rising in him. "Because the atmosphere is being used as a receiver." 10 minutes. The magnetosphere jolted inward. Lights flickered across the eastern seaboard. Signals scrambled. Data dropped. And for the first time since the pulses began, Atlas glowed. A dim, rising radiance, white at the center, blue at the edges, shimmering like a star under tension. The coma peeled away. Not blown, dismissed. The light intensified, and inside the glare the first shadow emerged. A shape, angular, impossible. Kent saw the image stream and whispered, "That's not a comet. That's not even close." 1 minute. Atlas reached peak luminosity. The ozone fractures aligned. The magnetosphere rang like struck glass. And something humanity had no word for, appeared between the object and Earth. A column of structured energy. Not a beam, not a flare.
A channel, a conductive line carved between worlds. Ruiz's voice cracked. "It's locked on." Kent whispered, "It's ready." Luke stared at the sky and whispered, "Oh God." The world hung suspended on the edge of an unknown. And then, the eighth pulse fired. A light not meant for human eyes. A force not meant for a living world. A resonance that pushed through every layer of the atmosphere, through the magnetosphere, through instruments, through the Earth itself. And then everything went silent. Not quiet, silent. Like reality had paused, waiting. And in that 6.6-second stillness, three truths crystallized. Atlas was no longer hiding. The atmosphere had been shaped for a purpose, and Earth had just responded. To what? That's what Part 5 will answer, because the pulse didn't just hit the atmosphere, it changed it. And when the readings returned, scientists saw something that made every model, every assumption, every hope collapse at once. The ozone layer had not only fractured, it had begun to break apart. The countdown to understanding had ended. The countdown to consequences had begun. When the sensors came back online, no one knew, at first, what they were looking at. The screens rebooted slowly, like wounded animals trying to breathe again. Lines of data flickered and staggered. Graphs reassembled themselves in pieces. For 10 seconds, the world waited in a half-born silence. Then the numbers stabilized, and every scientist who saw them felt the same cold, instinctive drop in their stomach. The ozone layer wasn't thinning, it wasn't degrading, it wasn't destabilizing, it was breaking. The fractures had grown not linearly, not gradually, but explosively. Their edges glowed in ultraviolet assays, expanding outward like cracks racing across glass under pressure. Regions that had been stable for decades were now collapsing by the hour. 1.6% global structural loss, not cumulative, per pulse. And the eighth pulse had been stronger than all the previous ones combined. Dr. Elias Ruiz stared at the wall of ozone maps, his breath shallow and uneven. The pattern wasn't random, wasn't chaotic. It circled the southern hemisphere like a tightening spiral, expanding outward from a precise locus, an atmospheric node directly beneath the place where Atlas had fired. A perfect alignment, a perfect correspondence. "This isn't destruction," he whispered. "This is construction." Around him, NOAA analysts turned slowly, confusion and terror bending their faces into unnatural shapes. "What are you talking about?" someone asked. Ruiz zoomed in. The fractures weren't branching, they were curving, each one bent toward the next, forming arcs of identical radius. Those arcs connected into loops. The loops nested into spirals. It was a pattern, a global-scale pattern carved into the atmosphere by an object millions of miles away. Ruiz said, "This is scaffolding, atmospheric scaffolding." The room fell silent, because scaffolding meant something was being built, and nothing on Earth had the power to build with the sky. Across the country, at MIT, Dr. Amelia Kent watched the magnetosphere begin to recoil from the pulse. Slowly, sluggishly, like a living thing trying to lift itself off the ground after being slammed by a force far beyond its weight. The magnetometer screamed with noise, but beneath the distortion she could hear it, the low, rhythmic thrum she'd been tracking ever since the second pulse. Only now the thrum had changed. The harmonic ripple was no longer matching the object, it was matching Earth. She replayed the signal, just 6 seconds of recorded resonance, and felt her skin crawl. The two waves, object and planet, were synchronized, not vaguely, not approximately, perfectly. "Elias," she whispered into her headset, "the planet is oscillating back." Ruiz, still staring at the ozone fractures, asked, "What do you mean back?" It responded, Amelia said. The pulse triggered a return signal. Earth's magnetosphere answered. How? I don't know. I don't know what mechanism could do that. But this wasn't natural resonance. Natural resonance decays. She pointed at the waveform. This one grew. She leaned back in her chair, her chest tight. Elias, it's like the planet completed a handshake. At Pine Ridge Observatory, Luke Harrison reviewed the last few frames captured before Atlas dimmed again. What he saw there would haunt him forever. The coma had vanished almost entirely, like a curtain being drawn aside. Beneath it, in the last coherent frame before the pulse washed out the sensors, was something Luke could barely comprehend. Sharp ridges, flat surfaces, an internal structure arranged in concentric shells, each rotating at slightly different speeds. Not debris, not ice, not dust. Something engineered. Right before the pulse blinded the telescope, the inner shell shifted. Just a fraction of a degree. But it moved with coordination, with intention, as if aligning itself, as if aiming. Luke played the frame again, zooming into a region that had originally looked like a blur. This time he saw it clearly. A central void, circular, symmetrical, black as interstellar night. A hollow aperture, a barrel, a lens. The pulse had not just emitted from Atlas, it had been launched. He felt his breath tremble. It fired at us. It actually fired at us. A tremor of fear ran through him so intensely his knees went weak. But the fear wasn't the worst part. The worst part was that the pulse didn't seem intended to
We believe Atlas is shaping the atmosphere into a resonant structure. Purpose unknown, a general leaned forward. Could it be a weapon? Ruiz shook his head. The pattern is too delicate, too geometrically coherent. This isn't dispersal. It's optimization. Optimization for what? Ruiz hesitated. Kent answered instead. For signal clarity, she said. Communication, transmission, reception, something in that category. The general rubbed his temples. Are you telling me the Earth's atmosphere is being turned into, what, a radio dish? Kent frowned. Not exactly. More like a translation medium. The CIA liaison spoke next. The president wants to know if this is an attack. Ruiz turned toward him, eyes heavy. I don't think this is an attack, he said. I think we might be in the way of something else. The room sank into uneasy silence. What do you mean, in the way? The liaison asked. Ruiz pointed at the spiral pattern. This structure is too large, too systematic, too old in design logic to be aimed solely at us. Earth might simply be the correct substrate, the correct chemical composition, the correct magnetic geometry, the correct atmospheric thickness. He exhaled. It's possible this mechanism was designed without regard for the life on a planet it interacts with. The general stared at him. So this could kill us by accident? Ruiz didn't answer. He didn't have to. Around the world, ultraviolet radiation levels spiked unevenly. Not enough to cause mass casualties, not yet, but enough to burn leaves. Enough to disrupt bird navigational patterns, enough for pilots to report instruments glitching at 30,000 feet. Hospitals near the equator began reporting clusters of sudden severe UV burns. Animals behaved strangely, cetaceans beaching themselves, night-migrating birds launching into daylight, bees leaving hives and not returning. The planet was reacting. But the object was quiet. For the first time since the pulses began, Atlas emitted no secondary glow, no faint oscillations, no thermal readings. It was completely dark, like a device in standby mode, saving power, waiting for the next command. 8 hours before the 9th pulse, something new happened. The magnetosphere didn't just deform, it flipped polarity for 0.07 seconds before snapping back like a bruised tendon. Every compass on Earth twitched, power grids flickered, radio frequencies drifted, GPS satellites threw errors that nearly grounded commercial air travel. Kent monitored the distortion and whispered, "It's tuning us." No one argued, because that's exactly what it felt like. 6 hours. Atlas brightened again, not gradually, instantly, like a floodlight thrown on in a cave. Luke Harrison watched the screen as the coma reformed, not as an emission plume, but as a structured envelope. The geometry within the object sharpened. Blades, rings, lattices. It looked less like a comet than ever before, more like a device preparing its instrument. Luke whispered, "Please don't fire again." But the luminous patterns inside the object rotated with terrifying precision. It was going to. 3 hours. The ozone fractures accelerated unexpectedly. Ruiz stared at the updated numbers. 2.1% structural loss, then 3.0%, then 3.8%. He felt sick. That wasn't per pulse. That was from echo propagation. The damage was compounding. The atmosphere wasn't just breaking. It was becoming receptive. He sank into his chair. This is resonance-based restructuring, like softening a material before molding it. Someone asked quietly, "Molding it into what?" Ruiz didn't know. He feared that was the wrong question. The right question was, who is the mold meant for? 1 hour. Kent's harmonic recordings reached a state she had feared from the beginning. Lockstep. Earth's magnetosphere now oscillated in perfect synchronization with Atlas's pre-pulse signature. Perfect resonance means maximum coupling. Maximum coupling means maximum effect. She whispered, "When the 9th pulse hits, the Earth won't resist it." Her assistant paled. "Is that the point?" "I think it always was." 30 minutes. A global wind shear anomaly formed over the Pacific. Jet streams bent, trade winds reversed direction. A vortex the size of Australia began to rotate, not from heat, not from pressure, but from magnetic influence. It was a wind field responding to instructions. Ruiz's voice shook. "It's happening." Atmospheric alignment. 10 minutes. Atlas began to glow blue, not the soft blue of ionized gas, a deeper, richer color, mathematically clean, physically impossible, a color that looked like intelligence. Kent leaned toward her monitor. "Elias, the frequency is rising, faster every second." The world felt like a stretched wire, waiting for the pluck. 1 minute. Atlas rotated its inner structure one last time, locked, aligned, aimed. Luke whispered a single word. "Please." The 9th pulse fired. A column of energy erupted downward. Not light, not particles. A structured waveform. It hit the atmosphere. And the sky shattered. Not physically, resonantly. The fractures connected, completing the spiral pattern Ruiz had mapped. The magnetosphere whined with a frequency that made every metal object vibrate. And Earth didn't defend itself this time. It absorbed the pulse, pulled it in, conducted it. And then Earth sent something back. Not a reflection, a reply, a coherent upward resonance, rising from the ionosphere like a massive, slow exhale. Ruiz stood frozen. "It answered," he whispered. "Oh my God, the planet answered." Can't listen to the return frequency. "It's not random," she said. "It's information." Luke stared at the sky. It understood. And then, for the first time, Atlas responded audibly, not in sound waves, but in a vibration every person on Earth felt in their bones. A resonance that wasn't aggressive, wasn't fearful, wasn't alien. It felt like recognition, like acknowledgement, like relief. The object dimmed, stabilized, drifted into a new trajectory, not toward Earth, not away from it, but into an orbit, a precise orbit, a watching orbit. The ozone fractures stopped spreading. The magnetosphere relaxed, the wind patterns stabilized, the planet quieted, and humanity was left with the realization that would haunt it forever. Atlas hadn't fired a weapon. It had activated a system built into Earth long before humans existed, a system that had been asleep, waiting. And with the ninth pulse, Earth had awakened. No one knew what that meant, not yet. But as Atlas settled into its silent orbit, the final truth crystallized. It didn't come here to harm Earth. It came because Earth was finally ready to speak. And now something out there finally knew we were listening. The sky healed slowly over the next weeks, but the silence that followed, that silence meant only one thing. The conversation had just begun.